Hello students, welcome to the next video lecture on centrifugal casting.
What is centrifugal casting? So in this casting process, the mold is rotated at a very high speed of 300 to 3000 rpm so that a centrifugal force is developed inside the mold cavity, and it will distribute the molten material to the outer region of a die cavity. So just see, so let us see this mold, where you can able to see some molding arrangements where you will pour your molten material and you will allow this mold to rotate at 300 to 3000 rpm. What it will happen means, so once we are trying to rotate this mold, there will be a development of centrifugal force. This centrifugal force will lead this molten material to drag towards the mold, towards the inner surface of the mold, so that the higher density material will be stick over the inner surface, and less density or impurities will be formed in the inner surface of a casting. So this is the centrifugal force, where we are going to develop such force by rotating the mold about 300 to 3000 rpm, and we are going to pour the molten material to have our casting. Okay, what is the difference between the sand and the centrifugal casting? So the very primary difference between the sand and the centrifugal casting is the mold, the arrangement of a mold. So in sand casting, it is a disposable mold casting, and that means it is a temporary mold, whereas this centrifugal casting is non-disposable, that means the permanent casting. What it means once the casting is completed, in sand casting we will throw that sand mold after the casting, whereas in the centrifugal casting you will reuse the mold for a different number of a casting process. There in sand casting you will have a separate set of arrangements called pattern material delivery systems like runner riser, which was constructed using some hardwoods or plastic. So such kind of arrangements you won't see in the centrifugal casting. So generally that mold is made up of any steel or refractory materials. So in sand casting process, sand containing bonding materials is packed around the pattern, and such kind of a thing is called as a sand mold. Here you don't have such kind of arrangements. So generally the permanent mold will be rotated either in a horizontal direction or a vertical direction. So the process of a casting in sand casting is nothing but you will pour the molten material into the sand mold, and you will allow to solidify for few minutes or few minutes, then you will get the casted part. Whereas in the centrifugal casting you will pour the molten material into the mold, and you will allow that mold to rotate at a speed of 300 to 3000 rpm, and you will let to solidify, and you will get the casted part. So these are the different parts which was produced using centrifugal casting. So long pipe or bearings, gears, so such kind of a product you can able to use, able to produce using centrifugal casting. What are the advantages and disadvantages of this centrifugal casting? So advantages, it is suitable for all metals and alloys and used for larger casting like pipes, hollow structures we can able to produce using this centrifugal casting, and also it possesses a good mechanical properties when compared to the sand casting process. Also it is having some few disadvantages, this is not suitable for intricate casting. What we have seen in the sand casting, by keeping some core structures inside the mold cavity we can able to produce some intricate structures, but whereas in the centrifugal casting we can't able to produce such kind of intricate structures, and the manufacturing cost is very high when compared to the sand casting. And these are the materials which can be used in the centrifugal casting to produce the parts. It starts from iron, steel, stainless steel, and some alloys of aluminum, copper, and nickel. And also you can able to use gold and silver for some jewelry application, right? So this centrifugal casting process are also used in the jewelry applications also. So what are the materials we can use for produce the molds? Whereas in the sand casting we'll use some green sand and dry sand, some refractive materials like silica, graphite. So such kind of a materials is used to produce our sand mold. No. So likewise in centrifugal casting, steel, iron, same graphite and carbon and any refractive materials can be used to produce our mold. So generally there are three types of centrifugal casting. Starts from true centrifugal, semi-centrifugal and centrifugal casting. We shall see it one by one. So first true centrifugal casting. So this is arrangement of true centrifugal casting. So this molten material is poured into the rotating mold. So this is the rotating mold. This is the end view, right? So our molten material is poured inside the mold, and we will let the mold to rotate about some defined speed, that is 300 to 3000 rpm. So this will produce some centrifugal force, right? So this rotation may be the horizontal, vertical or any inclined axis, that is between 0 to 90 degree, right? So once we are letting this roller to rotate at some particular speed, so there will be some formation of a centrifugal force. That force will drag our molten material towards the wall of a mold, right? Once we are trying to rotate, simply you can able to take a tumbler and pour your water and put some stones or sands inside to that, rotate that tumbler. You can able to see that sand and stones will be dragged towards the wall, right? So due to the centrifugal force, so such kind of a principle is happened in this process also, and the material is dragged towards this wall, right? As I said before, the alloys consist of a different density material, right? So that high density material will be dragged over the outside of a casting, right? So at the outside you can able to have some high density material, and low density and impurities will be formed at the inner section, right? So inner section, so that after completing the casting we can remove the part from that, and we can easily machine the inner surface to remove the impurities, so that such kind of a the part which was getting from this kind of a casting, so the impurities can be highly minimized. So again the mold is made up of steel, iron or any graphite materials, or a refractory lining is given inside the mold to increase the life of the mold. So coming back to the advantages and disadvantages, this process is quick and economical rather than the other methods, and some kind of a gating systems is also eliminated. Ferrous and non-ferrous materials cannot be casted, can be casted in this material, and it possesses a good surface finish. Coming back to the disadvantages, the material composition of alloy is not uniform, because at the outer surface there will be some material composition, at the inner surface there will be another material composition, and the mechanical properties also vary due to the different material composition inside the casting. And this is good only for the cylindrical components, not for any intricate structures or any solid structures, right? So these are the different parts which was casted using our true centrifugal casting process, right? So since the true centrifugal casting is made for only the circular component and the larger component, we cannot able to do some intricate structures or any solid parts. So then there is a next type of a casting process came into play, that is nothing but the semi-centrifugal casting, where you can able to see that structure is somewhat similar to our sand casting process, right? So here you will have the cope and drag boxes, and also you will have the pouring basin and the core to have inner hollow structures, all other things. So instead of that, you will rotate this complete mold at the speed of 300 to 3000. So we can say it is a kind of a hybrid where we can able to mix the sand casting with the centrifugal casting. The process is same, right? You are having the same structure, same mold structure, where you are having cope, drag and all the mold cavity, right, and the core box, right? So what you are going to do is you are going to pour the molten material inside the mold cavity, and you are trying to rotate that mold to the speed of 3000 rpm. then there will be a formation of a centrifugal force, right? So this centrifugal force is drag this material towards the end, right? So and the molten material will be get solidified. The process is same. After completing the casting, the dense material will be formed at the outer surface, right? So here the dense material will be formed, and at the this is the center of rotation, right? So this is the center of rotation. At this center, very less density of a material will be formed, so that after getting the casting, so there will be some difference in the density throughout the pot. That is one of the disadvantages in the semi-centrifugal casting. So what are the advantages? So number of molds can be stacked together. So for an example, so this is one set of mold, and the same kind of mold can be kept over this, and you can able to pour, so that you can at a time you can able to get two type of casting, right? So this is also having some good surface finish and ensure the purity. And coming back to the disadvantages, the rotation speed is less when compared to the two centrifugal casting, and this process is used only for the symmetrical pot, not asymmetrical pot can be produced, and the yield value is very less when compared to the true centrifugal casting, right? So these are the few applications of semi-centrifugal casting, where you can able to see a large flywheels with the spokes and pulleys can be produced using this semi-centrifugal casting. Coming to the last type of centrifugal casting is nothing but centrifuge casting. So the main disadvantage of semi-centrifugal casting is there is a variation of pot density in the casted pot. So to overcome that, some set of difference to be carried out in the arrangement, right? So what is the difference? So they have introduced the runner system in the semi-centrifugal casting process, right? So they have fixed the mold cavity at the end. Since at the end, towards the wall only, we are getting the high density material. So that what they have did is they have fixed this mold cavity towards the end, and they have introduced the runner system, so that once we are pouring the molten material into the mold cavity and we are trying to rotate that, so this and it will produce some centrifugal force, this molten material will travel towards the mold cavity using this runner. So that what it will happen, again this is the center of a rotation, so this is the center of a rotation, okay? So very near to this center of rotation, we will get a lens density material, and the high dense material will be formed at the end of a part. So this is the schematic, and this is the part which was get from the centrifuge casting. You can able to see this black dots is there, no? So that is less dense material, right? So this is high density material. After completing the casting, we can easily remove this by doing some machining operation. Okay, so this is how the centrifuge casting is produced. So the advantages and disadvantages of centrifuge castings are irregular shapes can be casted like bearings, caps, small brackets, and this is also ensure better quality, and this casting have high yield, rejection percentage is very low. Coming back to the disadvantages, this type of a casting is possible only in the vertical direction. We cannot use in any horizontal direction, since we are using the runner system. When you are trying to rotate in the horizontal direction, there is no possibility of rising the material using the runner. And also you can able to see, using this centrifuge casting, we can able to make different set of a casting, right? So asymmetrical parts can be done using this centrifuge casting, and different structures can be casted using this centrifuge casting.